We are the team from Victor, and we're here to show you how to correctly terminate a 15,000 volt Victor cable coupler. This is a typical mining cable coupler which are used throughout the world on most of the open cast large mines. We can see the three power phases, the main earth and the pilot configuration, where you can have up to 4 pilots to use as safety trips or for communications or other functions that the mine may require for feeding shovels, drills, drag lines, etc. Okay, one of the main functions of this Victor cable coupler is the clamping arrangement. Where we've had weaknesses in the past, the clamping arrangement has been changed, where it's a one-piece unit. The cable enters through a rubber grommet, which is sealed 360 degrees round the cable when compressed, and is forced against the wall of the cable coupler. This ensures 100% tight fit and no water ingression. Okay, we will now open the cable coupler, ready for termination. Okay. Okay. As we can see here, the insulator, a one-piece insulator with the body, etc., and the cable fastening unit at the back, or the cable clamping unit at the back. Okay, this is the compression rubber of Fortisure, which compresses against the external of the cable and the internal of the cable coupler. Okay. Right, what we need now is the cable. Now, this is a typical 70 millimeter mining cable, rubber cable, with individually screened with metallic screens, and this particular cable has 3 pilots. It's not necessary to use all 3 pilots. A lot of the mines use a single pilot and parallel them, which gives them a greater efficiency on pilot control. Okay. This is our typical mining rubber trailing cable, which we'll now prepare for termination into the coupler. Our coupler comes with a length of cable, of sheath, which we must now remove, okay, and the distance is given in the chart. Okay. This particular trailing cable, the sheath has to be removed to a distance of 300 millimeters, okay, which we will now do. First we will measure our 300 millimeters mark. And cut and remove the outer sheath. The cable I will explain in detail once the sheath has been removed. This is your typical mining trailing cable with your sheath removed. As we can see, we have the 3 power conductors. This particular cable has 3 pilot wires or pilot control wires of 10 millimeter. This particular power conductor is 70 millimeter. Your earth is the combine of the 3 metallic screens around the cable. We will now remove the nylon braid which holds the the screens together. Okay. We will tie back the pilots so as not interfere, while we use a heat gun to remove the nylon braid. The nylon interstices has been removed from the screen. We can now plait the metallic braid to form our earth. This now becomes our earth conductor, which forms 50% of the main power conductor. Okay. We will now terminate each conductor. Again, we have the termination cutting chart, which gives us the dimensions, which we take from the outer sheath of the cable to remove the semiconducted material from over the insulated core. Okay. We will measure 60 millimeters from the crutch of the external of the cable. We will mark with PVC tape, or we will put a layer of PVC tape over where we will cut. Okay. 60 millimeters there. We will take the tape round and leave the tape at the top, so that when we come to take off the semiconductor, all the tapes will be on the top, so you're not feeling for where the edge of the cable is, especially for some of the old cables which are not a semiconductive extrusion but a cloth wound with carbon inside. We will lightly cut the end of the cable to expose the layer of the semiconductive material, so that we can unwind and expose the insulation. If we damage at this point in time the cable insulation, we must start again. We lightly create with a knife 2 tram lines, again being careful that we don't go through the extruded semiconductive material into the insulation. And we'll see now we can peel off this semiconductive material with relative ease. We will now remove the PVC tape, which holds into place the semiconductive tape over the insulation. Okay, we can now proceed to stress relieve the cable at the crutch, where the semiconductive material ends and the insulation begins. That's where we will apply our stress relief tape. We will apply it 40 millimeters onto the semiconductive material in half-lap layers, and 40 millimeters past the cutoff of semiconductive material onto the insulation. This particular termination is for 11,000 volts. When we increase our voltage, we also need to increase the length of stress control that we apply. We have a stress control application with the relative dimensions, how long to apply the stress control material over the semiconductor onto the insulation. To hold the stress control insulation in place, we will apply a self-bonding, a self-amalgamating high voltage anti-corona rubber tape. Note that the high voltage rubber tape is stretched to approximately 2/3 of its size. This expels any air that is left in the termination. Air causes ionization, which causes premature failure. So the objective is to expel all the air within the termination, within the crutch of the cable. Okay, we will now proceed to do the other 2 remaining phases, and then we can apply the crimp adapters or solder the connectors on the contacts onto the cable end. Once they have been stress relieved and the crimp adapters or soldered contacts are on the end of the cable, we will proceed to clean the cable of any carbon deposits that may still be on, or any salts or dirt that we have on our hands. We will now proceed to fit the crimp adapters to the prepared cable. Okay. The cable has been prepared for these particular crimp adapters, so it's already been pre-marked, so the crimp adapters fit precisely up to the end. Okay. The crimp adapter will be crimped fully along the whole length of the shaft of the crimp adapter. Right, we'll proceed until all 3 cables, all 3 cores have the crimp adapter fitted and compressed. We are now ready to fit the male contacts to the crimp adapters. These particular ones are screwed, not soldered. However, should you prefer solder, if the size of the cable is stipulated, we will give you contacts with the correct size hole pre-drilled. Until extremely tight and the sealing rubber pushed into position. This we repeat on all 3 phases. When all 3 phases are crimped and the contacts secured, we can now crimp the pilot contact into place. Pilots are crimped in place. Thank you. Okay, the bell and the back clamp housing have been pre-fitted before the contacts take place. It makes life much easier. We will now tape up to the level of the insulation and over the bare copper onto the insulation of the conductor. Okay. Note that the tape should be pulled to 2/3 its existing width to expel all air. Okay, all taped up, we are now ready to fit the insulator. With the lock rings provided with the cupola, the insulator is locked into place and each one secured in position tightly. Okay. The pilot contacts can be now be fitted to the pilot to the insulator and secured in position. We are now ready to measure off the earth conductor, fit onto the crimp adapter together with the bell earth. The bell earth is very important. This links the bell to the true earth, getting it down to zero potential if any misadventure should happen during use. Is that your phone or mine? Oh, sorry. Okay, good. Okay. Yeah. Okay. Note the indexing on the bell and the insulator. Okay, which ensures the cupola. All right. Can you lift the bell up? Insulator in place. We can now lock the male body. Also, the location indicator pin, okay, corresponds to the earth position. Can you lift it up, please? There we go. We repeat this action until all the 6 studs are securing the male body onto the cupola. Okay. We now slide the cable clamp, and the bell have been pre-fitted before the cupola was terminated. The clamp arrangement, the cable clamping arrangement is now tightened sufficiently to grip the cable 360 degrees and act as a complete water barrier. The coupler has been fitted with stainless steel inserts to allow the gland to be torqued down into position without stripping the aluminium. The coupler is now 100% intact and is now ready for either pressure testing or putting into production and switching in. Thank you very much.